So hello guys, welcome to this video. So in this video we are going to talk about the basics of blockchain. This is going to be a mildly simple video to grasp, and it's going to be a beginner friendly video, and we are just going to explore the very basics of it. We are not going into the development part of it. We are not going to talk about the advanced stuff like smart contracts or stuff like those. We are just going to talk about the basic overview of what exactly blockchains are, what exactly Bitcoin is, Ethereum is, and why do we need these blockchains, why do we need these cryptocurrencies, why they can solve the issues that the current uh, world is facing in terms of privacy and data issues and stuff like those. And we are going to also look at the features of blockchain and why they are so safe and why we should consider shifting to these. And apart from those, these are going to just be like theoretical stuff. We are also going to talk about a little bit of hashing. Specifically, we will be talking about just one hashing algorithm. There are numerous, so you can look at a bunch of them after this video. And we are also going to look at an algorithm known as the consensus algorithm. What is it? And basically, there are a lot of consensus algorithms, but specifically today we'll be looking at proof of work. There are many more, proof of stake, and many more. So, apart from that, the last topic we are going to cover is key pair cryptography. So, by the end of the video, what we are trying to achieve is that you as a viewer can grasp the very basics of blockchain. And if you are like asked about what blockchain is really is and why should we like consider moving to those, like you must have heard web3, you must have heard dApps, decentralized apps. So what really are those and why should we consider using those? So that's what we are going to discuss today, and we're going to get a lot of knowledge in this video. So that's what the intro of this. So let's jump into the video. So first of all, let's talk about what exactly is a blockchain. So just a second, let me put this up. So a blockchain is basically a digital ledger. So what do I mean by a digital ledger? Okay, so a digital ledger is basically, you can think of it as a like a sheet of paper in which whatever activity is going inside the network, all those activities are basically noted in this ledger. Okay, so whatever activity is going inside the network, all of those activities is like noted down in this uh, piece of paper. You can think of it in this way. So this is what a ledger is. If you go to a shop, like any type of shops, they all maintain a ledger. So if you just look at the ledger they are maintaining, what all things do they write in that ledger? Basically, they write how many basically items we sold today, how much sales we did this month, uh, what customers are we selling to, basically collecting the customer data, basically just keeping a record of all the transactions our shop has done. So that's basically what a ledger is. Now, what do I mean by digital ledger? So instead of just maintaining it as a physical paper, just think of it as a digitized piece of paper in which every transaction that you make inside the network, like let's say uh, I give you my bank details, not like the whole private stuff, but just details enough to send me money, and you transfer me some money, let's say 100 rupees. So that transaction will be recorded in the digital ledger. So that's basically what a ledger is, and that's what basically digitizing it means. And blockchain is just a digital ledger. And how it works basically is that currently, like if I like send you some money over through like the bank transfer and all, so just think of it in terms of like maintaining a record of that. So that's basically what blockchains are. They maintain a record of what's happening in the network. Okay. And they maintain it at a very large scale. Okay. And that's basically why blockchains are so safe and why blockchains are preferred by like over the current infrastructure, the current internet infrastructure we currently have. It's preferred over that. So that's basically a very brief overview of what basically blockchain means. Okay. So let me just give you another example to make it more clear. So let's say by network, like I was saying that there are transactions in the network. They basically contribute to the ledger. So by network, what do I mean? So let's say that uh, me and other nine of you, so 10 of us, we create a WhatsApp group, and uh, whatever messages we are sharing among us, or whatever basically you can think of it as transactions we are having among us. Okay, so that's being recorded in some place. And basically what happens is that you can think of it as the digital ledger that I was talking about. So let's say there is some 11th person who is responsible for keeping record of all the stuff that is happening among the 10 of us. So let's say that I sent a message to one of you, or let's say all of you. So that is being recorded by the 11th person. So he maintains a digital ledger. And we can basically verify that I indeed sent you some money, or I indeed sent you some message by referring to that digital ledger. So that's basically why blockchains are so helpful. They basically help us to keep a record of the all the transaction and stuff, and they are also safe and secure in the sense that uh, all the transactions are actually public. So there is basically you can verify that the transactions are actually correct or not, or they are fake or not. Okay, so that's basically what blockchains are, and that's basically what digital ledgers are. So moving on to like why the need for blockchains. So the very first blockchain uh, that came into the market was Bitcoin, and uh, it was around 2008 2009. And uh, during that time, basically what the problem was, you must have heard of the financial housing crisis which happened in the US around that time only. And what were the reasons for that crisis? The reasons were very simple. Uh, the banks, the very big banks in the US, they went bankrupt, and due to those, uh, basically the common public, the people who had their lifetime savings, their maybe some investments in the bank and stuff like those, they all lost their money. And apart from that, they a lot of people also lost their jobs, and a lot of people also lost their houses and stuff like those. So during that time, what the general public realized is that the banks have a lot of central power over the money that we own, and that is not a good sign. And the housing crisis was actually not caused just by this, but it was a very key factor to the crisis. Because you see, like let's say that I put in, uh, I've been working, let's say I'm 50-year-old, and I've been saving, let's say, 10 lakh rupees every year, and after like my retirement, I want to like take out that money and enjoy the rest of my life. But the bank goes bankrupt, and when I accuse them of not giving my money back, they don't do anything about it, and they just my money is gone, my hard-earned money is gone. So a lot of people, the general public, realize that this is not good. The banks should not have a very central authority over the money that we ourselves own. So people thought of like let's say that you are in this situation. So what would be the the very sensible thing, the sensible idea to think of? That would be to basically like creating maybe a new bank, or like creating a new currency. So what would you think of putting the features in the new currency or in the new bank? You would want it to be like not have a central power, and it should basically have decentralized power. What I mean by decentralized is that basically, let's say the bank, like let's have a decentralized bank, and it has 1 crore inside their lockers, and there are 10 people who put that 1 crore, 10 lakhs each. So let's say by decentralized power, what I mean is that the bank does not own that 1 crore. I own 10 lakh of that, and the other 9 people own their respective 10 lakhs. So the all 10 of us own respective part of the money that we ourselves own, and the bank, the intermediary, the it's just like a intermediary is just like providing a connection, like you can think of like the traditional banks, but just you have the ownership of the money that you put into the bank. So that's basically what decentralized banks or decentralization or decentralized networks work like this. And that's basically what blockchains are also in very simple terms. So that's the reason, not just the like only reason, but that's what basically gave rise to blockchains like Bitcoin and many more to come in the future, uh, like in 2014 or something, like to that period Ethereum came up, and many more blockchains, Solana, and now we have hundreds of blockchains and hundreds of cryptocurrencies. So basically, that's why the need for blockchain was uh, so high at that time. So that's why Bitcoin was invented in around 2008. It was uh, invented by a, yeah, his name is Satoshi Nakamoto, and basically this was the guy who invented Bitcoin. Now we actually don't know who this guy is, but let's leave that aside. You can research it, you can read more about it on the internet. Okay, so that's basically why the need for blockchains. And we have also talked about few features of blockchain also, but let's just like brief it up. Okay, so the first feature would be decentralized, because all the people in that particular network or in that particular group, you can say, they all have authority over their respective parts. And it's not like there is a central authority who owns everything. Okay. And apart from that, uh, this is the reason that why blockchain is so safe, it's so secure, and also much more factors like those. That's basically, we have covered basically what blockchain exactly is, why do we need blockchains, and what all features does blockchain have. So I've talked about all these. Now, like before, like going into like a bit of like the tech part of how blockchains work and stuff. So we need to cover some basic things, and the first one would be hashing. So in what do I mean by hashing? So hashing is basically, let's consider this example. So let's say that I have this text, okay, and let's say that this text over here it says hello. So what hashing does is basically converts it into some random gibberish, you can see. So it will convert it into something like this. This is this does not make sense to us, but it does make sense to the computer, to the algorithms who like created this stuff. So what does this help in? This basically helps in like let's say uh, I want to send you a message, and I want it to be encrypted. Okay. Basically, what that means is that the message that I'm sending to you, it should only be readable by you, and it should not be readable by anyone else on the network. So basically, I can like convert this message into something that can be only decrypted by you. And what do I mean by decryption is basically converting this gibberish back into the original text that it was derived from. So hashing is not exactly used in encryption and decryption, but I'm just giving a sense of how it can be used. So that's basically what hashing is. It's nothing but converting sensible text that makes sense to you into some random gibberish that does not make sense to you. That's basically just it. That's it. Now, what's the other features that hashing has? So basically, what happens is that let's say uh, I run a hashing algorithm on my computer and convert hello into this random thing. Okay, and you also run the hashing algorithm on your computer, and you put in the input as hello, and you will get this very same output. Why is that? Because hashing is deterministic. By deterministic, what I mean is basically uh, the same input will always have the same output, and it does not depend on what kind of operating system you have, or what kind of laptop you are using, or what device you are using. It does not depend on anything like that. It is deterministic, meaning that same input equals to same output in other machines also. Okay, so that's basically what deterministic work means. And what's the other feature? The other feature is that it's very hard to basically uh, like let's say that I provide you just this. Okay, I remove this, and I ask you convert this random gibberish thing to the original text it was. So it's not possible to convert this into the original. And why is that? Uh, Technically, it is possible, but it will take probably like thousands or maybe millions of years to convert this random thing into the original one. And why is that? So one thing to do is that let's say I take this, okay, and let's say instead of hashing, I use the algorithm as like let's just say I want to uh, like the original example, I want to get this random thing as the hashed value. So what I would do is that I will start with some random string. Let's say I start with A, then I move to B, and as I move along all the strings, I will see whether or not this text gives me this random hash value or not. Let's say then I might move to C, then D, then E, and so on. so much more. And then after maybe millions and billions or maybe trillions of tries later, I will reach hello, and that's when I will crack the hashed value and I will find the basically the original uh, input. But as you can see, this will take lots of compute power and lots of years. This might be, and not just might be, it will be possible by quantum computers in the future. So that's why quantum computing raises issues in privacy and things like that, because they are so fast. They can, like, if I feed this into a quantum computer in the future, maybe from 5 to 10 years from now, it will easily predict that okay, the original value was hello, because it has so much compute power. And not exactly just compute power, but you can, like, if you want, you can read more about it. So that's about it. And okay, so let's try uh, hashing on our browser. Okay, so as I said that we will be talking about just a particular hashing algorithm, and that is the SHA-256. Okay, so let's just try something. Okay, so let's just input anything and let's just try input hello. So this is the output. Okay, so this is the output and this is the hashed value. Okay, just like I said that it converts the input into some random gibberish, and this is the random gibberish. Okay, and apart from that, like, if you want to, like, discover, like, what's the full form of this or how does it work, you can research more about it in basically, yes, yeah. So you can read more about it over here. You can watch some videos and stuff. It's not very basic. You can go very deep into this. Okay, but just to, like, give you a context, uh, this is basically what this stands for is basically simple hashing algorithm, and the 256 is basically standing for the amount of bits that the output has. Now, if you don't know about bits, you can, I'm just gonna give you a very basic intro to bits, bytes, and basically data structures, like not data structures, basically how data is represented uh, in very minute level in the computers. So let's say that I have a number, let's say 12. So what do you think, whether this number will be stored as 12 in the computer or not? No, it will be not stored as 12 in the computer. It will be broken down into something you might be knowing, which is binary. Okay, you must be knowing what is binary. Binary is basically just ones and zeros. It is nothing more than that. It's just one and zero and just a combination of those. That's how the all the data in the computer is represented in the very, like, machine level. If you go deep into the uh, computer hardware, so that's basically what binary is. And basically what bits is basically the uh, like, let's say I want to convert 12 into binary. Let's say, let's just take a much more easier example. Let's say I want to convert 4 into binary. So the binary code for 4 is yeah, it's 100. Yeah, so the binary code for 4 is 100. Okay, so just remember that bits is basically the number of digits in the binary code of the number. That's basically what bits is. So how many bits are there? This one has 3 bits. Okay, just remember that. So basically the output will have how many? 256 bits. But you might be thinking that if I count this, this comes to be around, I think, around 58 or 64, something like that. That's basically it's converted into bytes. uh, 1 byte is equal to 4 bits, so you can like divide 56 by 4 and you will get that how many the number of digits are there in the output. Okay, so you can go to this URL and you can like play around with the input and see how is it working. Like uh, as I said that this is deterministic. So if I enter hello over here, it's starting with something like 2CF. So in your computer, if you try it, it will also start with 2CF. So this is all about hashing. This is the very basic uh, intro to hashing and specifically how SHA-256 works. Not exactly how it works, but just we just looked at what it basically means and stuff. And moving on to the consensus algorithm. Okay, so just before when in the start, when we were like understanding blockchain as a digital ledger, so I gave you example that 10 of us have a WhatsApp group, and there is a 11th person who keeps a record of all the transactions that we 10 of us are having among us. So how does he record all the transaction? Okay, now let's say that 11th person is not an honest man. He is a very dishonest man, and so what he does is basically uh, like he injects some transactions into the ledger of his own choice that in reality didn't even happen among the 10 of us. So, what we can do to prevent this? So, we can do something like whenever that 11th person is basically writing something into the ledger, or like basically whenever something new uh, appears into the ledger, or something some new transaction is added to the ledger. It could be from my end, it could be from some other person's end. So we all need to like kind of have a voting system. Okay, like let's say that in order for a transaction to be noted into the ledger, it has to has a minimum of 6 out of 10 votes. That's when the transaction will be added to the ledger. And that's kind of like what consensus algorithm works like and what basically it means. So basically what it means is that the whole network has to agree as a not like the whole network has to agree to something like to some transaction or stuff, so that it could be like added to the ledger, so that it could be like added to the blockchain. And if they are not agreed by all the people on the network, it will be discarded. That's basically what consensus algorithm is. And how this works is basically there are a lot of consensus algorithm. The very basic one, which Bitcoin uses till now, and that's basically proof of work. And today we are just going to talk about proof of work. We are not going to go deep dive into the other algorithms. We're just going to look into the proof of work and how it works and just the basic stuff. And consensus algorithms are there are many more. The other one is proof of stake. There are many like you can search types of consensus algorithms. Yeah, you can read more about them. There is, just like I said, proof of stake. There is BFT. Uh, these are used by much newer uh, blockchains. Okay, but Bitcoin uses the proof of work, and that's what we are going to talk about today. Okay, so what proof of work basically means? Okay, so okay, So basically, what does proof of work means? Like, if you just read the word and just you can like interpret from it, it makes sense that okay, I have to show some proof of or some kind of like evidence, some kind of proof of some work that I'm doing. That's basically what this word is suggesting to us. Is that right? Yeah, it's kind of like that only. So basically, let's say that uh, I want to add a new transaction to the ledger to the blockchain. So somehow I need to like let's say that I add the transaction to the blockchain. So it has to be like okay, it has to basically be kind of like accepted or kind of like agreed by all the people on the network. That's only when the blockchain will accept this transaction from my end. Otherwise it will discard it. So how it will work in proof of work is basically let's say that I add the transaction and there is someone on the network who basically you can think of we will also delve into how it works, but let's say that he solves some puzzles, solves a very basic puzzle or it could be like a very complex puzzle also. So he solves that puzzle, he gets the answer to it, and then what happens is that he shares that with all the other people on the network. Okay, and then all the other people in the network can verify that the person was indeed right and his answer was correct. He indeed cracked the puzzle and indeed the transaction was valid and it should be allowed on the blockchain. That's basically how proof of work uh, consensus algorithm works. So basically, as you can see, like the person that solved the puzzle and he basically shared the kind of like the answer with all the people on the network. What happened is basically he did some work. What was the work? He solved some puzzle. Then he shared his proof. Okay, it you can like think of it like this. Very simple. Okay, let's say that I uh, like there is this Reddit forum or Quora forum in which I or like a Brainly forum in which I submit some uh, question related to some math theorem or something like that. And there is some person who solved it, who wrote all the proving steps of the problem and how he got the answer and okay, this is the correct answer and all of that. And he submits it to uh, this forum. So all the other people can basically like check the proof on their end and see that okay, he's he has got the right answer, this is right, and they can just upvote uh, his answer. That's basically agreeing with his answer. Okay, his proof is right, his answer is correct. So that's basically how proof of work consensus algorithm works. So I hope that you understood how proof of work basically works. And we are also going to look at uh, how the puzzles are solved and what really are the puzzles. So we are going to also look into that. Uh, but before that, um, I'll talk about like just like maybe like 5 minutes about key pair cryptography, what is like key pairs and what is public key, what is private key, stuff like those. And then we'll move on to like you can say not exactly practical stuff, but just like I will show you what exactly the puzzles are and how people solve them and stuff like this. Okay, so enough about consensus algorithm. So what is key pair cryptography? Okay, so uh, as I said in the very starting, not in the very starting, when I was uh, explaining to you about hashing, I said that it you can think hashing in usage of encryption and decryption, but they are not exactly used in encryption and decryption. Uh, in those, basically something else is used, and they what what is basically used is basically we use key pair cryptography. Okay, so basically just think of, like, just take this example. Okay, like yeah. So what key pair basically means is that there is a pair of keys. What the pair consists is that basically it has a public key and a private key. So the public key is basically, uh, as the name suggests, it's viewable by the public. Okay, you can share it with anyone. And uh, the private key, as the name suggests, it should remain private and it should only be reserved with you solely, and it should not be shared with anyone else. So that's basically uh, what the key pair cryptography uh, like means. So what does this help in is basically, uh, let's say, let's go back to our original example of the WhatsApp group of 10 people, and let's say that I send you some message saying, let's say, okay, let's take this example. Let's say I send you message saying hi. Let's say I'm saying it to you, hello. So let's just say it shows my name over here, ID over here. Okay. So how can you, like, kind of verify that okay, this was sent from my end only? How can even the blockchain verify that? How can even you verify that? So there is a concept known as private public key signing. We will also look much into it and you can explore more on it. But what basically happens is that you can think of it in very simple terms. Like whenever, like, you must have sent some digital signature on emails, like uh, let's say you want to fill some form of your college uh, via email or on some online portal. So what happens is that don't you don't, like, uh, sign a physical signature. What you do is basically you attach your digital signature to that form, and it's basically verified, and it says that okay, this is verified by you and this was indeed signed by you, and it proves that okay, this document was created by you only. That's basically what key signing, or how private and public key signing works. So that's how it works also. Just a few more jargons to add to it. Apart from that, uh, you must have used Digiyatra or apps like all the government apps in which basically don't remember the name or whatever. So all the apps, like, you must have seen digital signatures like okay, it is verified by the government or verified by some person, or it has been verified by you. So you attach. So how is it verified? You attach your signature to it. Okay. So in the blockchain world, it's very similar. Okay. You attach some signature to it, and what the signature is basically uh, is through the private and public key. Okay, so what you do is that you use the public key and the private key to basically sign this message. Okay, it can be something like, okay, okay, I can basically like sign this message that indeed it was me who wanted to send this transaction to the blockchain, and it has been verified, it has been signed by my end. So I will use my private key to sign it. Okay, and how will the blockchain like assess that okay, indeed it was signed by me and it is not someone else who is signing it from my end? It will use my public key, and it will kind of like uh, match it with my private key. Not exactly match it, it will kind of like you can see that you can say that it will kind of see whether the public key uh, of the signature is is the actual pair of that private key through which this message was signed, and only if it's true, that's when the message will be verified by the blockchain. That's how you will also uh, get a like verification or get assurance that okay, this message was indeed sent by me, this was not someone faking my profile. So that's basically what public key private key cryptography works. You can delve more into this, you can research more about this, feel free to do that, but that's what the basics are. And so yeah, we have like covered all the theoretical parts, but like just to like uh, inject more ideas into your brain, give you more understanding about this, I'm going to show you a blockchain demo also, and we are just going to like revise all the topics we learned in this video through this demo. It's going to take about 10 to 15 minutes. Okay, so let's okay. So you can try this. Just search blockchain simulator. And there will be this guy named Anders Brownwood. You can go to this website and you can even try this out on your end also. I will also provide this link. So first of all, let's visit the hash thing. So for the hash to for the hashing and for the SHA-256 hash, I already provided you a tool. You can check this out, or you can check this out also. Like as you can see, like this hello over here, it says this. Now if I copy this and visit this, okay, I can verify. Okay, it is deterministic. Okay, so indeed hashes are deterministic. They don't depend on what kind of device or some sort of like uh, devices you are or platform that you are using, and they are indeed uh, deterministic. So you must be remembering about hashes by now and how they work. Basically, it's converting some input into sensible input into some non-sensible gibberish output. Now, if I like visit this block, okay. Now, what basically blockchain is, just like I said, it's a digital ledger. So basically, in blockchain, the word block is basically you can say that it's a single transaction, or it can be even containing multiple transactions also, that single block. And like creating a chain of those, that's when we have a blockchain. Like just look at this. What all things does it have? What all details does it require? So the first thing is block number, just not necessary. We will talk about nonce in just a minute or two. And as you can see, this hash value. So how is it derived? So basically, this hash value is derived from the nonce and the data. Like basically you can say that I enter some nonce value. Uh, Apart from that, I also enter some data, and that's how basically the this hash value is calculated. So if I like type something like hello, you must have noticed this, that when it was the data field was empty, it was just like the original one, it was green colored. But when I wrote something, when I wrote hello into this, the color changed into red. Now, why is it? We will discover it in a minute or two. But for now, just look at into this tool, and just uh, what we care about right now is the data part and the hash part. The block part is not important, and we will talk about nonce in just a minute. So, okay, now let's talk about nonce. I think you must have got an idea of what blocks are. So, what basically nonce means is basically you can think of like this. Okay, like let's say I give a task to you, like yeah, yeah. So I give you a task to you. I say that I want uh, some string to be added before hello. Okay, so I want some random string to be added before hello. Okay, so that this whole string will be converted into a hash value, and that particular hash value will contain, let's say, four zeros in the start, and then it can contain basically anything. Okay, so let's say this is your task. So just to like give you an example, let's say the answer is somewhat like this or this, that when I add 402 in the start of the string hello, the hashed value that I get has four zeros in the start. So this will be my answer. What will be my answer? My answer will be 402. Okay, that's going to be answer. So how will you do this? You can try this code out. You can try it for yourself. Basically, this is the JavaScript library crypto. What it basically does is that you give a input to it, and it creates the hash from it, and you can see the hash value. We are using SHA-256 in this one. So how can you do this? This is very simple. If you want to try this challenge of finding the particular number that needs to be added in front of hello so that the hash value has four zeros in the start, what do you need to do is that basically you can like run this hash, basically this uh, process of getting the hash. You can run this in a loop, and you can basically increment this. You can basically like start from one hello, then two hello, then three, then four, and you can like go on till what, till the basically the uh, hash value contains four zeros in the start. Okay, you can do that. You can like solve this challenge, this small puzzle. You can solve it the end, uh, and you can like do this. And what the value that you get from this? Okay, in this case, let's say we get 242. So what the value that you get from this by solving this puzzle? This is basically what is known as nonce. This is basically what is nonce over here. So this is basically what nonce over here means. So what this basically means is that, let's say I add hello. So let's just leave it like this. So basically what this means is basically this data part represents this hello part. In this case, this data part is empty. but in this case the data pair is hello. So for empty string, the nonce is basically this. So basically what that means is that if I take this value, give it, and how many, yeah, 40. So basically what that means is that I take this and I convert it into a hashed value, that's when I will get 4 zeros in the start. And this is the nonce. Okay, this is the nonce for this. Okay, but if I type some data here, like my example, let's upload. So I just see the hash value now. It is not starting with zero, the 4 zeros, just like we wanted. Because what happened is basically, if I, let's say this is my string, okay, so this particular number was adding 4 zeros in the start of the hashed value for an empty string, but it will not add 4 zeros in the start for the string hello. So for the string hello, it might be something else. So how do we calculate that, or how do we find that? Basically, just click on this mine and it will find out. So the correct value is this one. So this one will particularly now be the nonce, and if I like hash this string, it will contain 4 zeros in the start, and as you can see, it is showing over here also. So that's basically what nonce means. That's basically what the data field part means, and you know how the hashing works. Now, if we talk about why this was turning green or red, right now it's green. So why is it that? Because like, let's say that I change it to some other data, it's turning red. Why is it? Because currently, as you can see, the hash does not have 4 zeros in the start. Okay, so that's why it's turning red. But if I want to turn this green, there are two ways. Either I can restore the data to the original data it was, which was hello. As you can see, it changed into green. Or what I can do is that if I want to inject some new data into this block, what I need to do is that I need to mine this block once again. So that's basically what mining means. You must have heard of like people mine bitcoins in their gaming GPUs and stuff like those. They are very high-end computers, and they use that to mine bitcoins, ethereums, and other cryptocurrencies. So this is what basically mining means. So mining in the sense of like in theoretical uh, part, you can just like understand it as a way of like creating more as like you can think of like creating more money, or like in the sense of cryptocurrencies, creating more tokens. Okay, that's basically what mining means. And in terms of like uh, mathematical or uh, basically the backend part of this, you can understand from this example. Okay, so that's basically what like uh, I'm hopeful that you must have like understood everything over here. So now we can move on to the blockchain. So just like we had a block, we had a single block over there. Currently we have 5 blocks over here. And this is what basically a blockchain is. It's just a chain of different blocks. Okay, so uh, like you must have already learned that basically this is the block number. It's not that significant. This is a nonce value. We have understood that. What's the data field? We have understood that. But we have also understood the hash part. But there's something new over here. That's basically the pref or the previous. So what this basically means is that this particular block, okay. Now, as I said that a blockchain is a chain of blocks. So there must be some way to link those blocks among themselves. Okay, so there must be some way so that all the blocks are connected with each other on that blockchain. So what basically is that this one contains the hash of the previous block. So if I just see this, it is AE8. This is also AE8. So this is basically storing the block, storing the hash of the previous block. Now, if you have learned about the linked list data structure, you must be knowing that in linked list, what basically it does is that it stores the address of the next element. You can think of it like it stores the address of the next block. So instead of like storing the address of the next block, you can think of it like here we are storing the address of the previous block. And instead of address, it is just storing the hash of the previous block, so that all the blocks are connected with each other on the blockchain. Okay, this is basically what this previous field means in this. So as I said, why this thing is green or red, we have also understood that. So now let's like try to make some changes in this. So if I like change the data a bit, as you can see, the hash value is changing. That's why this is turning red. So as I said, there are two ways. Either you change it to the original data or you mine this block. And that's only the two ways to turn this into green. And by red, what it basically means is that it will be not accepted by the blockchain and will be discarded. So let's say that I want to mine it. So I mine this. Now it's green. Now let's try something else. Now let's try changing the data over here. Like let's say I change it to high. Now in a previous example, the data in which the block in which we were changing the data, that's the block that was affected. No other block was affected by our actions. But in this case, as you can see, the right block is also affected by this. It has also changed to red. Now, why is that? Basically, what happens is that, as you can see, what we did, let's understand it step by step. So I changed the data over here. So the hash value of this particular block was changed. Okay. So earlier it was this. Now it is this. So the hash of this particular block changed. That's why this block turned red. Okay, we understand that. Next, why this block changed to red? Now, as you can see, the previous hash of this block that it's storing, it was something else before. The original one and this current one is not matching. So it sends that the data in the previous block has been changed. Okay, that's why this has also uh, been tampered and this is also now red. So how can I solve this? Just like our original thing, you can either restore the data to the original uh, data, or you can basically mine the block. So if I like mine the block now, as you can see, I mined this block, but this did not, uh, this block, all right, it worked in this, but this block, it is still red. So why is that? Basically, as you can see, the previous one, it is matching with this one. Yeah, that is correct. But the hash that it was the prev hash that it was originally storing, it is not matching with this one. So I need to mine this block also in order to match this prev hash with this prev hash. I mean this hash with this prev hash. So if I mine this, now it will convert to green. So now what do you think? If I change the data over here, how many blocks will change to red? Let's try that. If I just change the data, as you can see, all the blocks turned red. If I just restore it to original, all the blocks are now green. If I change something over here, the first were not affected, but the last three are affected. So from our example, we can understand that when we change the data in a block, all the blocks uh, after that block are affected by this, and there are either two ways to solve this issue. You can either change the data to the original data uh, in the block that you just made the changes, or you can mine all the blocks, uh, including the block that you made the change and all the blocks after that. So this is basically what blockchain is, and this is the particular reason why blockchains are so safe and secure. The reason is basically because, let's say, there is some hacker changes some data over here. So in the third block, so he needs to mine all the block, including third and after that all the blocks. So let's say that mining a block takes, let's say, 5 to 10 seconds, and this is just containing 5 blocks at this point of time. But the real blockchains, the Bitcoin, the Ethereum, those contains millions and millions of blocks. So it is not possible for a hacker to mine all of the blocks. So that's how the data cannot be tampered in a blockchain. And that's basically why blockchains are so safe, and why basically they are so secure. uh, you can like visit this website yourself, you can test it out. Okay, like let's just say, like let's just take this from some other example. Like let's say I send $100 to someone. Okay. And this is, let me just mine of the blocks. Yeah, so let's say that this is the original condition of the blockchain, that I send $100 to someone. So what will the hacker try to do is that, let's say he comes over here, and what he wants to do is that instead of transferring that $100 to the person that I wanted, he changes it to his personal account. So what he needs to do is that uh, either he can basically change this to original data, in which case the attack will not even happen, or he can initiate the attack. He can basically sit and mine all the blocks, and in our case it's just 5 blocks. But like I said, in uh, the like in the Bitcoin and the Ethereum blockchains, there are millions of blocks. So it's not possible for the hacker to do this. So in short, that's why it's so safe and secure. So by now we have covered all the topics. We have covered what exactly is a blockchain, why blockchains are needed, the features or the basic features of blockchains, how hashing works, specifically SHA-256, and how consensus algorithm works. Specifically, we talked about proof of work and how it works. We also looked at the practical aspect of it, of what the puzzles basically are and how it's solved, basically, or the practical stuff. Also, we also learned about key pair cryptography also. So I guess that's about it, and you can learn more about all these topics. I will also try to load more videos on this topic. So that's about it. So thank you.